students, welcome to Chemistry Kingdom. Due to some technical errors, I am unable to upload 2 videos in the last 2 days. So now onwards, that problem is already resolved. Now onwards, you will not get a problem. Daily, I will upload the video. Yes. So in the last class, we have finished SN1 and SN2 mechanism with comparative part, that is golden key points regarding SN1 and SN2 with stereochemistry. In today's class, we are going to discuss what are the possible questions which may ask in our upcoming NEET and KCET exams. Those things we are going to discuss now regarding SN1 and SN2. Different 15 variety of question I brought. 100% if you are getting the question, you will get from here only, because that type variety of questions I have brought, possible questions. Okay, so let us start without wasting time. What is the first question? And one more point, if you have not seen the previous video, first go through that, otherwise you will not get the question. This is competitive questions, right? So if you know the theory part, it will be easier. The whole in order, the link is given in the description. Please go through that and then come to this one. Yes, write the SN1 order for the following compounds. So 4 compounds given, 1, 2, 3, 4. They're asking SN1 order, means which is faster towards SN1 reaction. You know that SN1 reaction is favored by carbocation formation. In which of the following carbocation is more stable? That is going to your, yes, faster reaction. So let us say first one. What is given? What is the first option given there? pH, CH2. If you remove chlorine, what you are getting? Positive charge here. So this positive charge is stabilized by pH. What is pH? Benzene ring, phenyl ring. So that carbocation is stabilized by benzene ring. So here it is a resonance. What is present here? Resonance stabilization. Resonance stabilization, because it is a benzene ring. Double bond will come here and positive charge is stabilized. So in second thing, what is given? Let us say this chlorine will take and went as a Cl minus. So what you will get? You will get like this. Correct? Here positive charge. Carefully observe. 1, 2, 3. Here 1, 2, 3, 4, 5, 6, 7, 8. Clear? How many member ring is there here? 1, 2, 3, 4, 5, 6, 7, 8 member. 1, 2, 3, 4, 5, 6, 7, 8, 9. One more extra I have drawn here. Wait a moment. I will draw it. 8 member ring you have given. 8 member ring like this. 2, 4 and here like this. So carefully observe. This is double bond, double bond, double bond. Conjugate double bond is there, positive charge is there on this carbon. So clearly it is aromatic, guys. This is aromatic carbocation. It is more stable. You know that aromatic carbocations are more stable. First PU hydrocarbon chapter. Now coming to third example. If you talk about the third example, what is given in the third example? If this Cl is removed, then plus charge will come here. So what you will get? If here plus charge will come. Here this carbon is having here one side substituent, one side substituent, one side substituent. Total 3 substituent. It is tertiary carbocation. It is a tertiary carbocation. Resonance stabilized carbocation, aromatic carbocation, tertiary carbocation. Last one. If you take this chlorine here, plus charge will come here, and this is primary carbocation. Resonance, aromatic, tertiary, primary. Which is more stable? Obviously aromatic. Aromatic is more stable, means second will be highest. So you check the option, second is highest in the last option. Khatam. I hope you understood. SN1 order they are asking, you have to look for stability of carbocation. Aromatic carbocation is more stable than resonance, then it is more stable than tertiary, then it is more stable than primary. So order is 3 is greater than 1 is greater than, 2 is greater than 1 is greater than 3 is greater than 4, which is there in the option D. I hope you understood. So this is regarding first question. You just write down. I will go for the next question. Okay. Yes. Yes, guys. This is the second question. See here what is given. Write the SN1 order. Again, they are asking SN1 order. So these are the option. I told you SN1 order is predicted by stability of carbocation. Let us take this Cl minus will take the electron. Now what you are expecting in the first case? What you are expecting? Here positive charge, here single bond, double bond. So one double bond is there and here positive charge is there. Clearly again it is aromatic. Have you remembered first year hydrocarbon chapter? The compound to be aromatic, what is required? Odd number of double bonds and there should be either positive charge or negative charge. Means odd number of double bond, consider negative as a double bond, and all carbon should be sp2 hybridized. The molecule is planar and it should satisfy 4n plus 2 pi Huckel rule. Then it is called aromatic compound. First year hydrocarbon chapter, you go and read there, definitely will come to know. So this is a aromatic carbocation. This is a aromatic carbocation. Then you talk about the second option. What is given, guys? This Cl minus will take up. What you will get? Here positive will come. Is there any double bond? No. So it is a non-aromatic carbocation. Non-aromatic carbocation. Now coming to last option. If you take the Cl minus, what you will get? You will get like this. Here positive. Here even number of double bond. Obviously it is anti-aromatic. Anti-aromatic. You know that always aromatic is greater than non-aromatic is greater than anti-aromatic. If you talk about the stability, correct or not? So aromatic is greater than non-aromatic is greater than anti-aromatic. Stability if you talk about. So clearly aromatic is greater than sorry, non-aromatic is greater than anti-aromatic means 1 greater than 2 greater than 3. It is there in the third option. I hope you understood. So we'll talk about the next question. Just take down. What is given? Again they're asking SN1 order. These are the things given. Just I told SN1 order depends upon stability of carbocation. So first option will deal with what is given there, CH3T times 3CBr. If you remove Br, you will get plus charge here, which is containing 3 CH3 group. Means clearly like this, CH3, CH3, CH3 plus charge. Is it tertiary carbocation? Yes. Tertiary carbocation stabilized by inductive effect. Which effect? Inductive effect. 3 side inductive effect. Yes. Coming to this one, if you remove Br, plus charge will come here. So what you will write? Second one, C6H pi means nothing but benzene ring. C6H pi means what, guys? Nothing but benzene ring. 2 benzene ring attached to carbon. So how you will write it? One carbon is like this. So 2 benzene rings are attached to carbon. Here positive charge. This side one benzene ring and this side one benzene ring. And one side H. So clearly two resonance effect. Two side resonance effect. Resonance. Are you getting or not? Benzene ring means resonance stabilization of carbocation. Here this is stabilizing carbocation by inductive effect. Here it is resonance. Which is more stable? Resonance. Already studied first PUC GOC chapter. Yes. Coming to third option. So what is given there? 2 benzene, 1 CH3. Here only 2 resonance are there. Here C6H pi means benzene 2 times, phenyl ring 2 times and 1 CH3. So if you remove boron, plus charge will come here. So clearly 1 C, here carbocation, here one benzene ring, here one benzene ring and here CH3. Here one inductive, 2 resonance. What is there? 2 resonance plus 1 inductive. So which is highest stable because here H is there, here CH3 is there. Here only 2 side resonance, here 2 side resonance plus 1 inductive. It is highly stable, this carbocation. Coming to last point, what is given there? CH3 2 times CHBr means one side H, one side CH3, one side CH3. It is secondary carbocation, guys. Here plus charge will come. So what is there? It is a secondary carbocation. Secondary carbocation. Only what is there? Inductive effect. So clearly, guys, it is having 2 resonance plus 1 inductive, highly stable. So this third will be highest. Third is highest in which option? Last option. Third greater than, second greater than, first greater than last. Why like this, sir? Because resonance effect stabilizes more than the inductive effect. Here 2 resonance plus 1 inductive. So highest stable. Next 2 resonance. After this, second one. Here 3 inductive first, then only 2 inductive last. 3 is greater than 2 is greater than 1 is greater than 4, which is present in the option number D. If you don't know regarding resonance effect, inductive effect, you just go through the first year, first chapter of organic chemistry GOC. There you will come to know which is going to be stable, right? I hope you understood. Just take down. We'll go to next question. Guys, question number 4. What is given? Again, they're asking SN1 order only. So again, go for the stability of carbocation. If you remove Br, plus charge will come here. If you remove Br, plus charge will come here. If you remove Br, plus charge will come here. So what you are actually getting? You are going to get like this, correct? double, and here positive charge. Clearly it is aromatic because it is having odd number of double bonds. If you are talking here, it is secondary carbocation. It is secondary carbocation. Now coming to last case, it is anti-aromatic. Clearly it is a anti-aromatic double bond because two double bonds are there. Clearly it is a anti-aromatic, least stable. I told you aromatic is greater than, non-aromatic is greater than anti-aromatic. So clearly 1 is greater than, 2 is greater than 3. 1 is greater than, 2 is greater than 3 is present in the second option. I hope you understood. Yes, take down the screenshot. We'll go to next question. Next question, question number 5. Again, SN1 order only they're asking. So carefully see, already this question is most important. In several exams they have asked. Carefully see, here how many members? 7-membered ring, 3 double bonds. If you remove the Cl minus, you will get plus charge here. So clear, already studied 3 double bonds with plus charge. There is no sp3 hybridized carbon. All are sp2 hybridized carbon. 3 double bonds, odd number of double bonds, and planar. Clearly it is aromatic. First option is what? First option is aromatic, and if you go for this double bond will come here, this double bond will come here, this double bond will come here. So there is a 2 extended conjugation. 2 extended conjugations. 2 extended conjugations. Therefore, it is highly stable. Coming to second one, if you take here, plus charge will come here. 2 double bond, even number of double bond. Clearly it is. Yes, it is anti-aromatic. It is anti-aromatic, least stable. Anti-aromatic means least stable. Coming to this one, if you take here, what you are going to get? So if these electrons are taken by the chlorine, you will get plus charge here, and 1 double bond is there. Clearly it is aromatic, but only there is no conjugation. Extra double bonds are not there. Aromatic but no conjugation. Yes, aromatic compound but no conjugation. No conjugation. Correct? Yes. Now coming to this one, fourth one, if this Cl will take electron, here plus charge will come. This is stabilized by this one. I told you, when halogen is attached to next to carbon-carbon double bond, it is called allylic. First class classification of haloalkenes. If you have not seen that, link is given in the description. Please go through that. So this double bond will come here. So clearly it is called allylic carbocation. Which is that? Allylic carbocation. Allylic carbocation. Coming to last one, this electron is taken by here plus charge. It is secondary carbocation. There is no double bond, nothing. This is a secondary carbocation. Secondary carbocation. If you talk about the stability, aromatic and 2 extended conjugation is highest. Then aromatic but no conjugation. This is second highest. 1 is greater than 3. That you have to find out. 1 is greater than 3. 2 options are there. Aromatic greater than 2 extended, aromatic but no conjugation. Second one. Then coming to allylic, 1, 3, 4. 1, 3, 4, 5, 2. Because anti-aromatic is least stable. It is a least stable. So clearly 1 greater than 3, greater than 4, greater than 5. 1, 3, 4, 5, 2. Last option is there. Correct answer. I hope you understood. SN1 reaction is based on stability of carbocation. So I hope you understood this question. If you want to take screenshot, you can take it. We'll go to next question. Okay. Yes. Guys, question number 6. What they have given? This is called bridgehead position, guys. Remember this one. When this like a cyclohexane ring and here the bonds are taken. So this position is highly unstable. It is called a bridgehead position. What that is called? A bridgehead position. Here carbocation very least stable it is. Least stable. Talking about this, here if Cl is taken out, here positive charge will come. Second one, what you will get? You will get positive charge here with CH3. So this position 3 bonds are there. It is tertiary carbocation. Tertiary carbocation. Now coming to this, Cl minus is taken out, plus charge will come here. So what you will get there? You will get like this. Here CH2 plus. Here having only one substituent. Clearly it is primary carbocation. Which is more stable? Tertiary is more stable than primary, is more stable than bridgehead position. What this position is called? Bridgehead position, highly unstable. So clearly tertiary greater than primary, greater than least. 2 is greater than 3 is greater than 1. 2, 3, 1. Second option is the correct answer. I hope you understood. If you want to take screenshot, you can take it. We'll go to next question. Yes, guys, question number 7. What they're asking? Write the SN2 order for the following. I told you for SN1, what is the main point? Stability of carbocation. Like that, for SN2, what is the main point? Steric hindrance. If bulky group is there, reactivity is less. So you should get a smaller group. Exactly reverse of SN1. You know, in SN1, tertiary is more stable, but in SN2, primary is more stable. So clearly, primary gives faster reaction. So observe here, first one. In the first case, here Cl is given here Cl is given, Cl. So if you write first option, what is there? CH3, CH2, 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 and this is removed. So it is clearly primary, guys. What is this? Primary. If this is primary, clearly what you can say? Smaller group, easy attack. Primary carbocation. You can write primary. So next one, if you talk about second one Cl is attached here. CH3, CH2, CH, here Cl and here CH3. Clearly two substances are attached. So clearly it is this carbon is secondary. This carbon is secondary. This carbon we are talking. Talking about third one, what is there? Here Cl is attached. CH3 two times. So means here one CH3 is there. Next HCH2Cl. Here it is primary. This carbon is primary, but the next carbon is again, it is tertiary. Bulky group is there. Attack is again difficult. Coming to last option, this one CH3 ties. Clearly it is tertiary. Clearly it is a tertiary, guys. So you know in SN2 primary reactant will give faster reaction. So clearly one is greater than again primary is there here. 1 is greater than 3 is greater than 2 is greater than 3, because first this is also primary, guys. Halogen attached carbon is primary. Next carbon is tertiary, but doesn't matter. Talk about this carbon. First simple carbon. This is having carbocation if you write here, or Cl if you write here. This carbon is clearly primary carbon. Primary is greater than, this primary is greater than, secondary is greater than tertiary. 1 greater than, 3 greater than, 2 greater than 4. 1, 3, 2, 4. 1, 3, 2, 4. Last option is the correct answer for this. Remember, SN2 reaction, primary is greater than, secondary is greater than tertiary. I hope you understood. Take down, we'll go to 8th question. Still 7 questions are there. A different variety question we'll discuss. Okay, take down. 8 and 9. So what they're asking? Order towards SN2 reaction is, I told you, order of SN2 GK points. Have you remembered? If you have not seen that, link is given in the description. Please go through that video. Theory part of SN1 and SN2 GK points. So Ri, Rbr, Rcl, Rf, which gives faster reaction towards SN2 and SN1? Remember, either SN2 or SN1, always Rx bond should be broken. Rx bond is broken when that bond is weak, easily broken. When bond is weak, when bond length is more. When the bond length is more, when size is more. Are you getting my point? Fluorine, chlorine, bromine, iodine. Which is having more size, guys? Iodine. Iodine is having more size. Bond length is more, easily broken. If it is easily broken, obviously reaction gives faster. So which bond is weak? Iodine bond is weak. Then bromine. Are you getting this point? Fluorine, chlorine, bromine, iodine. Top to bottom, size increases. If size increases, bond length increases. If bond length increases, bond strength decreases, easily broken, faster reaction. So Ri greater than, Rbr greater than, Rcl greater than, Rf. This is the correct answer. If you have not seen that, link is given in the description. Please go through that. What is nothing but SN1 and SN2 mechanism. Okay. Now coming to next question. An SN2 reaction at asymmetric carbon. What is asymmetric, sir? Asymmetric means chiral carbon. Carbon attached to 4 different groups. Okay. An SN2 reaction at asymmetric carbon atom of the compound is always gives. You know that at asymmetric carbon means carbon having 4 different groups attached to it like this. This is called asymmetric carbon. When asymmetric carbon is there, you know that nucleophile is attack only on one side. Attack of nucleophile on single side. Hence, single stereoisomer is formed. That is nothing but inversion is formed. What is formed, guys? Inversion of configuration, reverse stereochemistry. That only I have written. Single stereoisomer is formed for SN2 mechanism. I hope you understood. So just to take a screenshot. Still 5 questions are there. We'll discuss. Take down. What is given? The compound which would undergo SN2 reaction faster. Which reaction undergo SN2 faster? They're asking. You know, smaller groups, primary groups, they are going to give fast SN2 reaction because backside attack is easier. I already told regarding this theory part. So tell me here, if you write, if Cl is there, here double bond is there, attack is very difficult. Here attack is easy, but how many groups are there? 1, 2, 3, 4. Here attack is very easy because 1, 2, 3. Only 3 are there. This will give faster reaction. This is tertiary, slowest reaction. So here it is primary. This is primary. This is secondary. And this is tertiary. You know that for SN2, what is the case? For SN2, primary greater than secondary greater than tertiary. Bulky group increases, SN2 reaction becomes slow. So 2 primary groups are there. Primary means you understood or not? Having one substituent, having one substituent. But here 1, 2, 3. Propyl group is attached to this carbon. 1, 2, 3, 4. Butyl group is attached to this carbon. Here propyl group 3 carbon. Here butyl group. So which is smaller group? Propyl group is a smaller group. Clearly C gives a faster reaction towards SN2 compared to remaining options given to us. Okay. So the next question, carefully observe. Intermediate in SN2 reaction. Already you studied. SN2 reaction is only one step mechanism. SN2 is a, yes, SN2 reaction is one step reaction. One step reaction without any intermediate. Without any intermediate. There are no intermediate in the SN2 reaction. Without any intermediate means there is no intermediate. So none of these is the correct answer because carbocation SN1. Carbanion pentavalent carbon 100% you will not get because SN2 mechanism is favored by single step mechanism. So clearly there is no intermediates formed in the SN2. Take down. So last 3 questions are there. We'll discuss and we'll complete today's class. Okay. Yes, take down. See guys, question number 12 and 13. Last 2 questions. Carefully observe. Which of the following condition favors SN2? I told you SN2 reaction is favored by polar aprotic solvent, strong nucleophile, one step mechanism, order is 2, molecularity is 2. I told you or not? So what is the solvent required there? Polar aprotic solvent is required. Polar aprotic solvent and strong nucleophile is required. Strong nucleophile. And I told you the order also. Order is primary greater than secondary greater than tertiary. So these are the main features of SN2 mechanism. What is given here? Strong nucleophile, yes. Weak nucleophile, wrong. Tertiary, wrong. Polar protic, 100% wrong. It is polar aprotic. This is also wrong. So what is the answer? Strong nucleophile is required. Means negative charged nucleophile usually. I told you this is regarding in theory class, previous class. If you have not seen that, link is given in the description. Please go through that. Coming to the 13th question, guys. Tertiary alkyl halides are practically inert to SN2. Means tertiary alkyl halides are practically inert to SN2. What is the reason they are asking? You know that tertiary alkyl halide has bulky groups. So backside attack by the nucleophile is very difficult. That bulky nature is called steric hindrance. This is because of steric hindrance. I hope you understood. So just take down. Last 2 questions are there. We will complete and we will complete this concept here only. Right? Yes, take down. See guys, question number 14. What is given? Order of SN2 for the following reaction they are asking. So this is carbonyl group given, Br given, Br given, Br given. First of all, I will write when this carbonyl group is there, this is called electron withdrawing group. What this is called? Electron withdrawing group. Remember, presence of electron withdrawing group. Electron withdrawing group. Withdrawing group increases. Presence of electron withdrawing group increases reactivity towards SN1, sorry, SN2. So clearly one is highest in the second option over answer. But remember, this one is given as a primary. See here, one Br is attached to here, and this entirely colored one substituent. This is primary. This is carbon is attached to here. This carbon is having only one substituent. This is also primary. This Br attached to this carbon. Here one substitution. Here one substitution. Total 2. This is a secondary. So primary greater than this primary greater than secondary. So 1, 2, 3, 4. 1, 2, 3, 4. This is there in the second option. Remember this note point, guys. What is that? Presence of electron withdrawing group increases the reactivity towards SN2. I hope you understood. So whatever the type of possible questions which can be asked from the SN1 and SN2 stability, I have taken. Last one more question. I will just give it as a homework. You have to comment your answer. Take down this one. Last question. What they're asking? Order of SN2 for the following. These are the questions given. Already this type of question already I have solved. So just you try yourself and comment your answer. Comment your answer for this question. Okay, some of you are not seeing the video only. Some of you are seeing but not replying. Comment your answer for this question, guys. Because already I told you, SN2 reaction is favored by smaller groups, not bulky groups. I hope you understood. This video is helpful to you. If it is helpful to you, please share the video among your friends so that every student can get a benefit of it. ನಿಮಗೆ ತಿಳಿದಿದ್ರೆ ದಯವಿಟ್ಟು ನಿಮ್ಮ ಫ್ರೆಂಡ್ಸ್ ಜೊತೆಗೆ ಶೇರ್ ಮಾಡಿ ಮತ್ತೆ ಈ ಮತ್ತು ಮುಂದೆ ವಿಡಿಯೋಗಳನ್ನ ಮಾಡಲಿಕ್ಕೆ ಸ್ಫೂರ್ತಿಯನ್ನು ತುಂಬಿ. ಸೊ ಇದು 15 ವೆರೈಟಿ ಆಫ್ ಕ್ವಶನ್ಸ್ ಅನ್ನ ತಗೊಂಡು ಬಂದಿದೆ. ಇದನ್ನ ಬಿಟ್ಟು ಮತ್ತೆ ಬೇರೆ ಕ್ವಶನ್ ಬರಕ್ ಚಾನ್ಸೇ ಇಲ್ಲ SN1 SN2 ಒಳಗೆ. ಓಕೆನಾ? ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ಒಳಗೆ ನೆಕ್ಸ್ಟ್ ಕಾನ್ಸೆಪ್ಟ್ ಅಂದ್ರೆ ರೋಮನ್ ನಂಬರ್ 1 ಮುಗಿತು. ಇಲ್ಲಿಗೆ ಏನು ನ್ಯೂಕ್ಲಿಯೋಫಿಲಿಕ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ರಿಯಾಕ್ಷನ್. So in the next class we will discuss about elimination reaction and reaction of metal, and then we'll start haloarenes. 4 more class will complete this chapter, and after that which chapter you want, please comment below. Yes, thanks for watching. Thank you. Jai Hind, Jai Kannadambe.